Problem 52, the reaction of magnesium metal with oxygen, O2, forms MgO. Write a balanced equation for this redox reaction. Write two half reactions to show how many electrons are gained or lost by each species. So the first part is to write the balanced equation, and we're told what the reactants are. So we have magnesium comes in the form of Mg, and oxygen comes in the form of O2. And the product is a single MgO. And to balance this, we got two oxygens over here, so we can put the 2 over there. That forces us to put the 2 on the magnesium, and there you go, it's balanced. Now, this right here, by the way, is a combination reaction. You got two substances combining to form a single substance. It's a combination reaction. Combination reactions usually are, or pretty much always are, redox reactions. So this is also a redox reaction. To figure out who is oxidized and who's reduced, we need to label the charges on everybody, or the oxidation states, whatever you want to call them. So first, let's do the hard one. This is an ionic compound, a metal and a nonmetal. Magnesium is a +2 ion, and oxygen's a -2 ion. You can see magnesium's in the +2 column over here. Oxygen is in the -2 column. So let's label the charges. This is +2 and -2. That's nice because the formula needs to balance. You got one of these and one of those, they balance. And then over here, these are simply elements. Okay, magnesium metal is an elemental substance. It does not have a charge. Okay, it has a charge when it's combined to oxygen. Now it's an ion in an ionic compound, but over here it's an element. It's just a neutral element. Okay, and same with oxygen. This is neutral oxygen, elemental oxygen gas, probably. So here this is also neutral. And we didn't put the states here, but you know, this is probably solid magnesium reacting with gaseous oxygen to form solid magnesium oxide. And what you're doing here is you're burning the magnesium. So magnesium burns in the presence of oxygen, and you're left with this white powder over here. And that's not too important. But after you've labeled the charges, you can see who's being oxidized. The magnesium starts off as neutral, and it goes up to +2. So that's where oxidation is occurring. So this is the particle that's being oxidized. And the oxygen is being reduced. So the O2 is reduced into the oxide anions. So the neutral O2 molecules are being reduced into the -2 charged oxide anions. So we can write the oxidation and reduction half reactions. First, the oxidation. So you have two magnesiums. And over on the right-hand side, they are two magnesium ions, and they are +2 ions. Since you got two of those +2 ions, that's a total of +4. So 4 electrons must have been released. Okay, for 2 atoms of magnesium to turn into 2 +2 ions of magnesium, 4 electrons must have been lost. And you can bet the 4 electrons are going to be gained on the reduction side. They always are. If you have this many lost, then this many are gained for reduction. So here you have one oxygen molecule. So we'll put O2, and that turns into 2 oxide anions. Okay, you have a total of -4 over here, and this is neutral. Well, for something neutral to turn into something -4, it must have gained 4 electrons. And so we'll write those next to the oxygen. Let me move this over a little bit and put those 4 electrons. And there we go.